6 years old. The easiest question to determine whether it'll work or not is, can it run XP? If you could run XP and actually have it like run in any semblance of form, 504 megs, whatever, a couple of gigs of hard drive, whatever, works fine to be a soft client. You take that off, instead of buying a brand new thin client, buy the software agent basically, install it. It's $30, $40, something like that for the software. Install it onto that old desktop, and it'll run Win 7. It itself can't run Win 7, but it can be a thin client to run a Windows 7 virtual desktop.
So this all feeds into the budgeting process, doesn't it?
Absolutely. If you have a mandate to roll everybody up to Windows 7, don't have the money to roll out brand new computers to everybody because the hardware requirements are a little bit higher. If you look at virtualizing that desktop infrastructure in the data center and push out VDI to those desktops with just a soft client, basically a piece of software, you convert it into basically a dumb terminal to receive a Windows 7 image. And all of a sudden, everybody's running Windows 7, you didn't buy a single PC. Yes?
What about GPU intensive applications? AutoCAD?
Actually, I'm going to let Pete do this. Pete came to Mosaic from a software developer in Bellevue. Is it Bellevue?
Yes.
Okay. They do a lot of this stuff, so I'll pass this over to Pete.
Well, yes, I did, and I actually just recently migrated from a software company that focused on data visualization software. So we were acutely aware of some of the challenges with regards to GPU-intensive applications, and that would include things like AutoCAD as well. And there are a couple of issues with GPU-intensive applications. One is that they relied entirely on the horsepower of the graphics card that was located in your physical system. So then the question becomes, if you no longer have this physical system, where is that horsepower going to come from? That's actually, there's a couple of different ways that can be approached. One is that a couple of the well-known hypervisor manufacturers for these virtualized desktop infrastructures are focusing specifically on cards that can be inserted in servers that will pass through that GPU-intensive processing that you would normally be afforded on a standalone system. The other side of it that can certainly be done in the meantime is that you can have a physical workstation that is located in the data center, and that is transmitting this PC over IP protocol in the very same way that a virtual machine does. And that is going to give you all of the GPU power that is in that physical workstation, but to the endpoint, which might be an iPad, a laptop, an iPhone, with that same GPU rendering capabilities. And that's something that they were employing last time.
So you're running ESX on the workstation in the data center?
No, the workstation itself is nothing more than a traditional workstation, and it has what's called a PC over IP postcard in it, and it has the VMware View software agent installed. And what's interesting is that the end user doesn't know whether it's physical or virtual. They are just simply seeing the results. And there's two things to really keep in mind with respect to PC over IP and this newer remote display protocol. One is that it's all host-based rendering, so you don't have to worry about the endpoint and the capabilities of the endpoint. And that's really unique and very different than traditional remote terminal sessions. You always had this issue where you were relying on some of the capabilities of the client, the endpoint, and what was serving that up. And it was very challenging. You would run into graphics driver updates and things of that sort. Generally didn't work out all that well. The other side is that PC over IP is non-connection oriented. Everything that runs over UDP, which is what most of us know if we're streaming audio. That is just by its very nature, traditional network connections really are built around the foundation of guaranteed reliable delivery of that data. What's interesting, and that's good for when we really need that guaranteed reliable data transmitted in an orderly fashion. The problem that can exist and that can show up in these different environments when you're trying to push the remote display is that what happens if a packet is lost or dropped? What happens if there's excessive latency there? That is the #1 preventer of anything moving forward as far as that screen being able to render the display like you want. It has to, simply by the nature of TCP/IP, it has to halt all transmission, retransmit, and then it can proceed forward. If we're transmitting video at 15 frames a second and it lost a packet from 4 frames ago, we really don't care about that. So this new protocol and this new way is really changing how some of these displays are rendered.
Yes.
So how about the VPN connection? How it works?
VPN connections, that's really interesting. Because in addition to having a thin client or a zero client or a soft client, you can also run the View client itself, or just a piece of software, on any Windows desktop. You can just download it and run it, and it will connect directly back through whatever connection you have, similar to what RDP, you just put in your username and password, connects right through. And also, as far as your question on horsepower, there's a View client for tablets. So there's no rendering and horsepower here. It's connect, go through, it's all set. As far as connecting from home, you connect to the internet comes in through your firewall, your View infrastructure, and then down to your virtual machine. Okay. First of all, from home, if you've established a VPN connection already back through your firewall into your network, you can simply fire off the client from your PC and it will work. That's assuming that you need to VPN in through your firewall. But even better, I mean, the downside is everybody who needs access to this needs to have the VPN client installed before they can get in.
So
one of the
kind of horsepower VPN computer.
Correct. So if you don't have a VPN but you still need to get in, View has a component called a security server that sits outside your firewall, is locked down, and has ports open for the View client right there. So it's a DMZ port that you have to open on the server. Well, it also creates a secure tunnel through your firewall back to that View server. So anybody without a VPN, as long as they have their login credentials, they log into the security server, which has an Atom database basically that has your username, your group information, so they can authenticate. Once they pass that authentication information back to actually say, yes, that is your true authentication, they will tunnel you back through to this. So now the user does not need a VPN, and they're tunneled through a secure gateway into that desktop. This comes into play a lot of times in education. We have several colleges that are deploying View for their lab environments. So they're building their computer labs, and instead of building one giant image that has every single piece of educational software on it, they're actually breaking it out. So they'll have a science lab image, an economy mathematics lab image, and then a couple other basic generic images or something. And based on Active Directory group policy, etc., students who are in a chemistry class are automatically in the science, chemistry group or whatever. So they will, by default, through domain permissions, group policy, have access to the chemistry image. They'll also have access to the generic image as well, because every student has it. Well, they could walk over to one of the labs, and when they log in, they're presented with whichever images that they have permission to, and they select it when they want. That lab image pops up, and they just work in it. Everything gets saved back to their home directories or whatever, so nothing's actually stored on that lab virtual machine. It all goes back to their home directories or whatever, so it's saved there. Well, they're done with that, they need to do some econ stuff, so they'll log out of the chemistry image or whatever, log back into the econ mathematics image and do their econ homework or whatever, and get out, and that's fine. Well, that would work great if they had to walk all the way over to the lab, computer lab to do this. But now every student has a PC. Why not just give them access from their desk, from their dormitories or whatever? So they're doing that. They're just opening it up, and through a security server that grants them access from on campus and off campus,